Okay, Roger from Mud Fossil University, and this is a simulation of gravity that I don't believe is understood now. What you have is a negative, and here you have a negative and a positive. The positiveness draws the negative, and the excessive negativeness keeps that negative at bay. That is quantum, and it is also the exact same reason for gravity. Now, let him shake this, and you'll see that does not want to leave, and it does not want to come closer. Okay, so he can make it go back and forth until finally it will go flying off into space. That is light. Shaking like that, that is heat. Sitting stable, that is a solid mass. There'll be a little bit of movement in them, but they're not going to be doing this kind of stuff. This is heat. Flying away is light. And we'll see this again at the end, and I'll show you how gravity works too. Alright, that's a normal light disk from a red pulsed laser floating through air. This is that same type of light disk over here that would have come in a nice rounded wave forward. Instead, hitting the venturi, it becomes highly accelerated, particulates and atomizes, and then steps back down in quantum states, back to its original spray of light. And eventually it will turn red again, and I'll show you that. Alright, this is the accelerator, and it appears to have accelerated this light, and as it comes out here it steps down, and it takes on less and less colors, and then it turns back into its red spinning disks. Alright, you saw the chaos at the slit with the camera facing down. This is facing into the slit, and we're seeing that accelerated light reforming, and you see some of them are stepping down in these different colors, that mean in different masses. They look like they're different compactions. That is that they are stepping down to their normal spinning. This one here, this is the one I want to point out. That is the one that is going to crash into another one of these disks and create what's called a light trumpet, which means that this highly accelerated particle, it's still a particle, is able to give off some of its own light. That means light can be divided in my mind, and I'm going to show you the evidence. Alright, this is that highly energized particle that I showed you before, floating amongst the slower particles. Now, and I say particles because you see it as a spinning disk here, but it's one particle that's spinning so fast it's seen as a disk. These are compressed, still in a highly energetic white state from the accelerator. They came through at a different angle, and these were less energetic coming through. This was more energetic coming through, as shown in that blue one that I showed before. Now, you can notice that you see the structure of the wave. It's now beginning, it crushed into this wave. It hit it. I don't know whether it hit particle to particle or field to field, whatever it was. It now has given off what I call a light trumpet, which is a portion of its accelerated energy. And it now has become one of these, or is becoming one of those, and has given off an excess portion of energy. This is light. I'm saying that's a particle. I'm saying that's a particle. This, I'm saying, is a 1 pound particle. This is a 10 pound particle, or a 1.2 pound particle, and that's a 0.2 pound particle. I don't know. It is something in that nature. This has more energy, which means it has more mass, and it has given up some of its mass. That's all I can determine from what I am seeing. Alright, this is light coming through the accelerator from here, spinning to the right, drifting to the left. This particle is one of those highly accelerated particles I'm going to show you that gives off the trumpet. You notice all of them expanded and compressing as they leave further away from the accelerator. All of them do the same things. They come through the accelerator at different energy rates because they're different spin factors, which means different angular momentums and different energy intensities. That's why this is a much more energized particle than the others. Alright, it appears they're like shock waves going forward, and you can see that's the bump of the particle, and whether it creates a shock wave or it's spinning, I can't tell you. I'm seeing what I'm seeing. You're seeing the same thing I'm seeing. Okay, it's Roger from Mud Fossil University, and I'm going to explain the net negative unified theory, which appears to solve the dark, spooky problems with Einsteinian theory. All right, so I'm going to go over this kind of quickly, and then I'm going to show you the examples that I can show that I believe prove that this is a fact. All right, now it's not a mainstream theory, obviously. So you're going to have to open your mind, just think about it. Don't just automatically dismiss things. All right, it was experiments in every single energy exchange, electricity and light and heat and chemistry, and every single way that energy is developed and exchanged. All right, so scrutinize this. Don't just avoid it. All right, now here's what you have to deal with. We only have three things in the whole universe that I know of, which is a neutron, a proton, and an electron. Now, here's the weights. 1.008, 1.007, and then an electron weighs almost nothing, 0.00005. When you add an electron to a proton, it equals a neutron virtually. The proton is just slightly less weight than a neutron. And my statement is that weight is mass, and mass is determined by the standing weight, which is the resting mass, times whatever forward motion it has, and take in the factor for the circular spinning, what they call angular momentum. It is literally the impact of a particle. That is what power and that is what energy is. Now, the proton is 837 times heavier than the electron. They don't even consider the electron. They don't even talk about them. They just like they don't weigh anything. Well, they do weigh something. They weigh a significant amount because there is a ton of them coming. Okay, so basically the mass of a proton and electron roughly equals the neutron. Electrons are light spinning at different frequencies. I'm saying electrons are light. They are particles. They spin off the sun, thrown off of there at such extreme radiations that they leave their nuclear orbits and spin off into space, unseen because they're negative, and they're all negative in space, so they don't interact with each other. Right? So the electrons are spinning different frequencies, creating different angular momentums and powers as they go through space. They're not all the same. And I have visual evidence to show this, all right? And I have a link to that. I claim all these particles are mass and have energy, and they are not at all, well, they wave as they go forward because they're spinning. If you look at it from the side, you're seeing an up and down wave, but it's actually a particle moving forward. And that's what I claim. They're not photons, they are electrons. Now, here's what you have to consider. Neutrons are always found with protons, 100%. They don't ever leave a proton, so they are together 100%. Neutrons are a tiny fraction more massive than the protons, as we saw, so they have a little more mass. Neutrons are always in the nucleus where the protons are. They're both stuck in the nucleus, which is the center, the core. Protons never, ever, ever exceed neutrons in a nucleus. So if you have a proton, you will have a neutron. If you have two protons, you will have two neutrons. If you have 5 protons, you have 5 neutrons minimum. You may have 6, 7, whatever. There may be additional neutrons, but there will never, ever, ever be less neutrons. So you always end up with more mass of the neutron than the proton. So neutrons can far exceed the number of protons in a nucleus. When you get way up into the heavy metals and things, there are many, many, many more neutrons than there is protons. All right, so therefore, the nucleus will always, always, always have more mass from the heavier neutrons. So we know we have a neutron mass, okay? Also, as atoms become more massive, they add additional neutrons, so the imbalance becomes more pronounced. This is the critical thing to take, is that neutrons are a little excessive to the protons, always having a more mass, and I am saying that more mass and that neutron is actually the same energy as an electron. So let's go on. Conclusions. As atoms add protons and electrons, they add neutrons. We know this for a fact. Often more neutrons than protons and become heavier in a neutron mass than a proton mass, just as we talked about a second ago. Now consider this. Neutrons are obviously not neutral. They're stuck together. We know that, and they are always found with the protons. And to separate them, you end up with Hiroshima atomic events, atomic bombs. That's the separating of the nuclear particles. We are dealing with light, the movement of electrons. The nucleuses we're dealing with stay together, but we're looking in the electron realm. All right. So these particles, which are the neutrons, are so extremely well attached to the protons in a nuclear mass called the nucleus that they are obviously not at all neutral, absolutely not neutral, and appear to be exactly opposite particles from the protons, creating extreme attraction to those protons. So they are held together and almost impossible to break, unless you want to do nuclear stuff. Now, there is an option to that, though, and it is with frequency. So we'll talk about that later. Now, consider this. We know the mass of neutrons is always greater than the mass of the protons in the nucleus, so there's no question. This claim I'm making is extremely simple. Neutrons can actually be considered the same charge as electrons, but they are massive. And in the core, these massive electron-charged masses, which are neutrons, are attached to the protons. They just are solidly, like, glued right together. There's no distance between it. Boom, they're solid. The positiveness, though, of the protons attracts electrons, which are outside of the nuclear mass, and they come towards the core. The electrons are drawn to the positiveness of the protons. And I show this in the experiments. I will show you absolutely no question whatsoever. The excess neutron mass creates negativeness, so we still have a negative core, and that repels the electrons to a quantum distance. So if this is +1 more negative than the core, they stay out 2 angstrom units. If it's +2 more negative than the core, they stay out 3 units. Let's talk about that way. That is the quantum distance and they stay there, and they do not want to go closer, and they do not want to go further. And we have seen that in that magnetic tractor beam that I showed you. All right, so they are out there, and that's just a fact of nature. They are there, and when you go to the video, you can see for yourself. Watch these videos. You know, study up on these things that are out there. Everybody's doing a lot of experiments. They're being very, they're thought of as games, but they're not. They're very serious. At 24 seconds in this video, you'll see the dual polarity charge. That is gravity, which is what I showed you before. And that is the nature of gravity. It pulls the negativeness of every particle, and when an electron is that negative particle, it pulls it down to the positiveness of the core. And when I speak about the core, when we talk about the Earth as the positiveness of a nuclear mass, and what it was traditionally called the ether, which is the electrons of the entire universe are flooded with them. It is the background of the universe is electrons. They get sucked down to Earth when they get close enough to approach that positiveness of the core. They get sucked down. They don't fall down. They get sucked down by gravity. That is my claim.